Today we are going to talk about fine-tuning and evaluating LLMs as part of LLMs for executives and dummies. So here are the topics we are going to cover. When to fine-tune models, common tools for training and fine-tuning, and LLM evaluation strategies. As a developer, for each LLM use case, you need to balance accuracy, which favors larger models, speed, which favors smaller models, and task-specific performance, which favors more narrowly fine-tuned models. A new generative LLM release is comprised of small, base, and large models. They're of multiple sequence lengths. For example, it could be 512, 4096, or 62,000. The flavors or fine-tuned versions could be base, chat, or instruct. So the base version could be, hey, I know that what word comes next. They'll predict the next token. The chat version would be, I know how to engage in conversation. Instruct version would be, I know how to respond to instructions. For example, do X, for example, do Google search, or go search a YouTube video. So here is a potential pipeline for summarizing news articles. So what we have is a news API and some pre-made examples. So, and what we could do is, we could do few shot learning with open source LLM, open source instruction following LLM, paid LLM as a service, or build your own LLM. So here's the pros and cons of few shot learning. In pros, we have speed of development, performance, and cost. In cons, we have data and size effect. In speed of development, it's easy to get started and working. For a larger model, the few examples often lead to good performance. In cost, since we're using released open LLM, we only pay for the computation. In data, it requires a good number of good quality examples that cover the intent of the task. In size effect, depending on how the base model was trained, we may need to use the largest version, which can be unwieldy on moderate hardware. Here's the pros and cons of instruction following LLMs. Pros is data, performance, cost. Cons is quality of fine-tuning, size effect. In data, it requires no few shot examples, just the instructions, occurs zero shot learning. Performance, depending on the data set used to train the base and fine-tune this model, it may already be well suited to the task. Cost, since we're using released open LLM, we only pay for the computation. In terms of cons, as I said, there's a quality of fine-tuning. If this model was not fine-tuned on similar data to the task, it will potentially perform poorly. Now, size effect, depending on how the base model was trained, we may need to use the largest version, which can be unwieldy on moderate hardware. Here's the pros and cons of LLM as a service. The pros is speed of development. It's easy to get started and working. As this is just another API call, it will fit easily into existing pipelines. Performance, since the processing is done server-side, you can use larger models for best performance. Cons. The primary cons is cost. You got to pay for each token sent and received. Data privacy and security. You may not know how your data is being used. And vendor lock-in. Susceptible to vendor outages, deprecated features, etc. And here's the pros and cons of fine-tuning an existing LLM. In pros, you have task tailoring, which means creating a task-specific model for your use case. Inference cost, more tailored models, often smaller, making them faster at inference time. Control, all of the data and model information stays entirely within your focus of control. Cons, there's a time and compute cost. This is most costly use of an LLM, as it will require both training time and computation time. Data requirements, larger models require larger data sets and skill sets. This requires in-house expertise. So how do we evaluate these LLMs? So of course, we have training, loss, and validation scores. So during the training, what do we watch? Like all deep learning models, we monitor the loss as we train LLMs. But for a good LLM, what does the loss really tell us? Nothing really. Nor do the other typical metrics like accuracy, F1, precision, recall, etc. Now let's discuss perplexity. A good language model will have high accuracy and low perplexity. So in the diagram, as you can see, the language model probability distribution, and where there is a spike, that is the next probable token. Now, accuracy means the next word is right or wrong. Perplexity means how confident the model is on that choice. So in LLMs, we can have task-specific metrics. Perplexity is better than just accuracy, but it still lacks measuring context and meaning. Each NLP task will have different metrics to focus on. And we are going to discuss two. One is blue, which is used for translation, and rouge metrics, which is used for summarization. Now, blue stands for bilingual evaluation under study. Blue uses reference sample of translated phrases to calculate n-gram matches. It could be unigram, bigram, trigram, or quadgram. So as you can see, there's a reference sentence, life is what happens when you're busy making other plans, and in output, you can measure like bigrams, trigrams, or single tokens, and see how neatly they overlap with the reference text. So the future evaluation in LLM chains. It's still a very new area of applied research. Only now are applications coming online, and best practices will continue to emerge. So here is our overall summary. So fine-tuning models can be useful or even necessary to ensure a good fit for the task. Fine-tuning is essentially the same as training, just starting from a checkpoint. Tools have been developed to improve training and fine-tuning processes. Evaluating a model is crucial for model efficacy testing. Generic evaluation tasks are good for all models, and specific evaluation tasks related to LLM focus are best for rigor. We are not done yet. As you might have noticed, I didn't talk about rouge metrics for summarization. So the rouge is defined as total matching n-grams divided by total n-grams possible. So rouge 1 means words, rouge 2 means measuring bigrams, rouge L means longest common subsequence, and so on and so forth. Thank you.